As you probably know, AI is already redefining the world economy, from financial services to healthcare to automotive, energy manufacturing, public sector. We're really starting to see great new AI applications come. And this is all in partnerships with NVIDIA, our great partner who has been pushing us on the envelope of innovation. So what we are talking about here is, yes, we've been here for many years, 27 years in fact, but the last 10 years has been amazing. In 2015, almost 10 years ago, we were supercharging superpods, DGX superpods. After that, NVIDIA was starting to use it more and more internally, and then we started using it with other scenarios. As you can see, XAI from 2024 is one of our largest implementations, the largest AI implementation both for training and inferencing. So these are just proof points. Only this year with Google Cloud, we launched a first-party service which includes all the managed Lustre services for training needs. So really impressive that we're going from on-prem to cloud and hybrid scenarios. And there are many from an NCP angle. You'll see many of them coming up and demanding for much more power, much more GPU utilization, much more acceleration, much more efficiency overall. So the key point is this AI infrastructure is really important for sovereign AI. It's really important for nation-scale AI. We started long back with Asia Pacific, Singapore, Indonesia, India, then in the EU location in France, UK, and now in the US. We're doing a lot of work in this space, and the focus is all about reliability, safety, security, data sovereignty, and control overall. This is essential because, as you know, without that data control, you cannot really get to good quality or good outcome of AI. So data quality is a focus, and that's why we are here today. You can see some of the logos of new properties who have started using it in very interesting ways. Mistral included, Nebius, Lambda, etc. So let's talk about nation-scale AI, right? When we're talking about AI factory for nation-scale AI, what does it mean? What are the challenges that people face? Let's think about it from Jensen's favorite model, which is, thinking about computer 1, computer 2, and computer 3 for training, inferencing, and then obviously for edge scenarios with physical AI. If you think about these three blocks at the higher level, it's all about how do I get to my data easily? How is it being made simpler, more efficient, more easy to use? How do I get to good data, really? Then for inferencing, if you think about it, it's all about agents today. But essentially, any AI app relies heavily on all of that data that's coming through with abilities to do post-training. As you saw from the presentation this morning in the keynote, there's a lot of emphasis and focus on that. Now, on the last part, physical AI, you're seeing the advent of robots and EV, AV machines coming together. And now the data volume is just increasing. It's going out of bounds, right? I'm going to show you one example about that. But what are the data issues behind the scenes? If you think about it, a lot of people are still doing ETL pipelines very manually, very slow and tedious. So we are using a lot of optimizations, GPU accelerated, using CUDA libraries, trying to make sure that all that governance, data sovereignty, everything is packaged together and works seamlessly as you release new solutions out there. So please keep in mind, at nation scale, we need to think about governance, control, and automation. Automation is important because, we cannot go to that scale without having that level of control. So if you think about it holistically, what are the resource limitations? Real-time data coming in. Are we able to adapt to it? Are we able to take that real-time data and ingest it, access it the way we want it, when we need it? We know a lot of data is not easy to find. And as you're trying to look for that data and trying to find where do we apply it, there's a validation scenario. How do you validate that data? Is it good quality or not? Then you face computational bottlenecks. You face issues with, your GPUs are either running too hot, completely utilized, or maybe they are not utilized very much. So now we need to think about how are you tackling the high data volume with whatever you have as resources, keeping costs in mind, keeping the whole aspect of manual activity in mind that it just increases day by day. So how do we reduce the manual data ingestion? How do we reduce the analyst workload? In today's scenario, the analysts are overloaded with so much data coming in. So we're thinking about these primary aspects when we think about resource limitations, high data volume, and analyst workload pressure. Now, in summary, what does it mean? We need to do more with less. How do we do more with less? Like, do we look at it from a GPU angle? How do we use GPUs in a more optimized manner? Do we look at it at a data integration? Like what's batch, what is real time, how quickly can you process? I know there's quite a few agencies out here today. They have loads and loads of data and very less, maybe 3% of that being accessed for real data, AI data workload. Then we have the aspect of how much time is it taking, right? It takes a lot of time to go through all of that. There's too many manual steps in the process. So automating that, making it easy for every data scientist, every engineer to use, AI application builder to use, is critical. And then finally, adaptability. We are seeing a huge onslaught of new types of multimodal data coming in. And that multimodal data is of such variety, from JSON files to videos and audio clips. We have to really think about how can we make it seamless and easy. So going back to that 3-computer model, in DDN, we have the product called XR6. It focuses on training, very efficient, very on-prem oriented for all that training activity that needs to be done. On the Omniverse side, as you heard in today's keynote as well, with physical AI coming in, you need more digital twinning. You need more virtual Omniverse type of scenarios. And that's where Infinia comes into play. And then finally, at the edge, we can take the same Infinia and deploy it at the edge for collection of data, for making sure that the processing is not all pent up and till the very end, till the very last end. So in that scenario, now let's take a scenario of space. We're talking about debris risk in space, in the orbit. In this particular scenario, you can see just from this example, we're getting 100 plus terabytes of imagery every day. We have ground stations, we have rocket ships, we have satellites in space, we have a lot of debris that's already collecting. And just one satellite produces 16 to 30 terabytes of data. So imagine the amount of data that's coming in. In this particular scenario, with all the new satellites that are coming up, imagine 6,000 new satellites coming in just with Starlink in 2026. So how do we reduce the risk? We need data to be collected. Yes, we are collecting a lot of data today, but are we able to process it in time? Are we able to build the right AI applications in time? So we have a demo of this at our booth number 241. You can come over and take a look at this scenario. But essentially what it shows is that if you imagine launching a mission-critical satellite out there and not delaying it, you need to think about all the debris that can cause risk in that scenario. And this is the architecture that we have come up with, where we are able to take all sorts of satellite imagery, footage from ground stations, any kind of seismic data, any data that's coming, and take all of that data within and process it through a standard blueprint from NVIDIA. And we are adding to that. We are making sure data can be made accessible. It's really optimized and easy to use. Now, if you think about the demo that you can see over there, there's an orbit tracking scenario, more than 1.3 terabits per second of data coming in. At the same time, you need to track it, identify, ingest it, identify the intelligence that is needed, identify the trajectory, do some cataloging and checking the inventory of debris that's already there, and then identifying actionable intelligence, which is essentially your alerts that you want to send out to the right department. So we have a lot of detail on this at the booth number 241. Please come over and take a look at it. So I want to give you the case study of Singtel here. Now, Singtel is one of our very first partners with sovereign AI, as well as with satellites, as well as country-wide sovereign AI applications that are coming through. And we have done many such in Asia Pacific, and we are starting to do in Europe and US too. But as you can see, what is critical over here is the CTO is saying that he needs the right balance between performance, economics, security, and the compliance aspect too, because this is sovereign AI, right? We are not talking about just doing this in a private backyard somewhere with some machine sitting. So please think about this aspect, that that's the value you can provide in sovereign AI. You can think about high performance data platform, but at the same time, a GPU accelerated environment where you're really able to use your GPUs efficiently, along with all the networking and all the storage that goes along with it, and keep your costs under control too. Costs just escalate once you start doing this, right? You add more GPUs, and then you have more things to consider. So this is a good example. There's a YouTube video link about Manoj talking about this in person. We are seeing the same pattern repeating in Singapore, Indonesia, Europe, and France, and in the US too. So something to learn from. So in conclusion, we have the AI data platform as a foundation. This data platform allows you to do most of those activities for training, inferencing, all of that covered over there. So faster time to value. And then we are trying to reduce the complexity and the overall TCO as well. So please think about that aspect, right? Can you add AI factory blocks on top of it? This is our visualization of how you would have a foundation. And on top of that foundation, you could add many ISV partner APIs, all the AI refineries, all kinds of tools and APIs and agents on top to make this much more easier. So we are trying to reduce the complexity, we are improving the performance, and we are going after broadening the ecosystem, because we welcome all partners to join us in this effort. And you can see that we are allowing you to create the foundation, add modules as you go, and some of these modules could be at the edge. Some of them could be in your data center. Some of them could be in cloud. And so all of those have to communicate very effectively together. And for that, we have ROI. We can share this ROI detail with you, how we are saving money. And we can talk about how it's powering, how this same infrastructure is currently powering more than 1 million GPUs across the world. So I'm going to end with just an example of how this data ocean, we call it the data ocean, how that is coming together. You'll be able to remove adoption hurdles. You'll be able to accelerate that data fabric, and then you'll be able to control the data in a very highly regulated environment. So that's our roadmap, our path. We are enabling gigafactories in Europe today. We are focusing on accelerating sovereign AI, and then we are thinking about a broader ecosystem, working with NVIDIA ecosystem to make sure all the connections are there. We are going through all the industry verticals, and we are focusing on foundational models, research models, NCP-related models, neoclouds, and also all of the specific ones in energy, defense, and public sector. So with that, I'd like to announce the release of our new platform. We are calling it the HyperPod. It's a data intelligence platform. I'm going to play back a short video clip. Just an hour ago, it was released out in the press. So please bear with us.